1 second. Present. Where are you at? Slash. Hello, everybody. My name is Ray. I'm here to present this digital timer using STM32F303K8 board. This is for CPE 187 embedded system design for the summer semester. And our objective today is just to make a digital watch, pretty much to mimic a real clock closely as possible using STM32. You need to keep track of time using, and I use OLED SSD 1306 display. It will sound alarm when set, have a knob and buttons. It use internal STM32 clock, real-time clock. I do have this Arduino module, but I won't be using it. In this demo, we'll be demonstrating that. And this is what we need: rotary encoder, wires, OLED display, module, yellow and blue. It's monochrome. So I used the Atkinson library that is on Canvas. We need breadboard, USB cable, passive buzzer, and our board. And this is, before we start, please download the library in our Canvas section named SD130806 Atkinson library, and then we'll be importing them like so. So this is what we're gonna select: that and that and that, and make sure to rename this a little bit and copy paste in here. And our test case will be make sure if the alarm actually beeps when the timer reach, and we'll display what we want, the knob actually working when twisting. And this is pretty much our block diagram. So the summary of it. So this is, I'll demonstrate in the demo in a bit. This is our program. It uses I2C to communicate with the STM32 and OLED display, and it's all powered. All of these are powered by oops, I don't know why that should be here, but all of these should be powered with 3.3 volt, that 3.3 volt, and this one communicate by PWM outputs, communicate with that, and that's a external interrupt, which is pretty much buttons. That's what it means. And next time, this is a real-time clock calculation. Pretty much instead of crystal clock, I use a low-speed internal oscillator known as LSI, which is this one. I set it to 40 kilohertz, and that is pretty much our base number. And then I just choose a number 128 division, and then our register value will be one less than that because it will be count to 0 to 128.7. And then I divide that by our clock number and I get that number. So that's how I get this asynchronous value and synchronous pre-divided value. And I use this in 24-hour format. Before I get this, I need to activate 1, 2, and 3, internal alarm A, activate calendar, activate clock source. And this is the initialization. I didn't have daylight saving on. That's the date, today date. That's alarm that we will set. So this is the same. You can edit this with the code too if you want. Saturday, August 22nd, year 26. That's the I'm setting this as 0, so it's easier. So this is for the buzzer, namely here. So we use it here, and division is gonna be 7, prescaler, and counter is 499, and everything is just the same. And this is our OLED display I2C, and that connected that 3.3 volt ground, and then everything else is pretty much the same. I think so. Oh, don't forget this I2C. And these are all of my GPIOs, which is pretty much rotary encoder, pretty much all in one. Let me see. I had to do the label differently. Clock and data, the switches, and it needs to be so PA0 is the clock. It's gonna be external interrupt mode with following edge trigger detection, and it's gonna be all pull up. These are the inputs, and don't forget to put the interrupt. Um, this should be line 17. External interrupt 0. Interesting. This is my demo. This is a demo for the watch clock. Let's reset it. Let's go. So that's the home screen, the date, Saturday, and the time. I set it to 0, so it's easy. So let's go on the next screen. That's a set alarm, and let me press the switch. Boom, set hour. I want it to be 0. And let's set minute. Let's go back down. 1 minute. Go. And once that oh no. Okay. Now we wait. That should beeps after a minute. Okay. It shows the date, and that's today, date, time, and that's our clock. Because I set it on my STM32 to be 000, that's why it's like this. Okay, overall conclusion of we successfully implemented clock, display, and knobs. The part need to work on. For a short time, this clock works accurately when it's like less than 1 hour or so. But when I let it sat for a day because I fell asleep, the clock error get bigger as time go on. So I probably need to research more on how to calculate this. The next step will be making into PCB to make it compact and add more functionality. Thank you for watching. And let's see the code. What time am I at? Oh, 9 minutes. Okay. Where are you at? So let's see the code at that and type def private function. These are all my initialized peripheral. That's my code. This is my external interrupt, pretty much all the screens. Allowing screen editing mode, press switch, and then that's the third switch to save. And that's, let me see. Oh, that's a buffer. It's a screen that say, oh, my alarm is there. Oh, these are all generated. That is my function code. These are pretty much saying that, oh, this day is that day. So switch statement, and this prints the day, the time on the menu, the home screen. These, pretty much these are in the demo in the lab. It's the same thing. This one is second screen, I believe. That that is the rotary encoder when I have to click it and no, turn it and it should like go back and go forward. This is going clockwise. Yeah, clockwise going forward. This is counterclockwise going backward. And this is the alarm system I set up. Yeah, I think that's it. This is generated. Oh no, wait. Yep. No, it's the same pretty much. Okay, I think that's pretty much it for me. Thank you.